Welcome to my channel. I'm Zhang Xu. Let's look at the problem 41 in chapter 9. Chapter 9 is about linear momentum. In this one, we can see in this model we have object 1 and the initial mass, the mass and the initial velocity for object 1 is given. And then we have the object B. It keeps stationary there. The mass is given and it connected with a spring. This spring constant is given K. So we can see A just moves to the right, and on a perfect surface, and just hit the object 2, and then A and 2 sticks together. So we need to find the maximum compression of the spring. How can we do that? So in this process, we can consider the first time the object 1 just hits object 2. There is no external force, so linear momentum is conserved. Then A and B, 1 and B sticks together, so we get a velocity V plus, right? And then in this process, we consider the energy is conserved. The energy is conserved, so initial energy equals final energy. So initial kinetic energy equals the final kinetic energy. Also, we need plus the energy stored in this spring, 1/2 kx squared. Agree? So then we can solve the problems. So at the first time V2 is 0, so we get the equation in this way, simplify in this way, and then we input the V plus inside in this equation, and then we can get the x1, right? Super easy. Now the second one asks you what will be the final velocity of the blocks after this collision. So in this one, we can see A and B hit each other, and then finally, it just moves by themselves, right? Because there is a spring, and sometimes we consider the A and B velocity after the collision separately, and then we consider the A hit B in this time. Is there any other forces? Just the forces comes from the spring, right? This is a conservative force, so that makes the energy conserved. Agree? So this is elastic collision. The momentum is conserved and also energy is conserved. Mechanical energy is conserved. So we can say first one we write the linear momentum is conserved, and then the kinetic energy is conserved, and then we know these two equations from our textbook. So there, I suggest you just remember this VA plus, VB plus from your textbook, so you don't need to solve these two equations. It saves a lot of time. And then you can see you get these two equations, and A and B are given. So you just input the known quantities, get the final answer. Easy. The third one is ask you, is this collision elastic? We just talk about it. Yes, it's definitely elastic collisions because also the forces is conservative forces, right? On the horizontal, we can see only the forces comes from the spring. This is the conservative force, so make the collision elastic. Thank you.